Okay, I have a brief introduction. Whatever we will do this week. Basically, it's the overview of what I will talk about. I will talk a little bit, just briefly, about the new product development. There's some theme about it. There are different approaches. I picked just one, and I think something similar you already see in Finland. Then we will do something technical questioning, which will tell us why we are doing what we are doing. And then we will go through a list of selected tests we will run through. And after that, maybe we should do some small break, and a graduate student will continue. Okay. So that's the basic scheme of the new product development. Mainly is used in the commercial area. There are some few steps which you have when you try to create some product and try to at the end commercialize it. You have to go through many steps till you get the product. And this motivation workshop is basically about you and how you about the product, and teach you and show you in practice what is it to get from initial idea until the end. So most of these business and marketing and commercialization will be done in partially, I guess, in Finland at the end of the workshop in January. But what we are doing right now in Poland, and what we will do in the short run, it's all about concept development and testing, plus this product development, which is kind of combined back and forth, improving the product. So, what's the main product we are dealing with? Question. I guess you should be familiar with the stuff we did in Finland, in Lahti.
Chlorine.
Salt?
Chlorine.
Okay.
Chlorine.
Chlorine, yes. So, yeah, one of the product is chlorine. The chlorine. Why we choose this technology we are using? What was the reason? We did some 2D shape pressing treatment, high temperature mixing in a press. So why we are doing this? What was the initial idea? We wanted to create better product for flooring, for example. But why all this fancy pressing and shaping and molding at the same time, drying, with lots of problems with cracks, as you already know from the last time? Any idea?
To reduce drying time and surface treatment time.
So we try to combine those technologies all together, and within a short time produce everything. To do drying, to do surface treatment, to do improvement or enhancement of the material properties all at the same time, and come up with the product which is comparable or even better of the common products, for example, for the floor. So there was some ideas. Those ideas were even before this workshop start, or this project start, because it was beginning or initially in the proposal of this project. But you went through this process. You tried to, or your colleagues tried to build this product, come up with some problems and describe them, try to find some solutions. It was all about this report which was done in Finland, in Finland. So recently we will do this concept development and testing and product development, which is also part of the stuff we did in lab. Let me explain just two phrases or two definitions. this product development process is basically entire set of activities, which is starts from the new concept and finish with the end product. But what we are doing, or what we will deal with, it's a design process, which is a set of technical activities within this development of new product process. And it does not include this business and financial and all these marketing activities and stuff. So this design process. And this is the basically idea which I took from Albert Einstein. We try to do, we have idea, we try to do this improvement of the product, and we try to find out and we try to measure it, how it is, if it's good or it's bad or it's better, and try to compare with some common materials. We always have to ask questions. We have to define what's the problem, and we have to find later on the solution. So Albert Einstein said that the formulation of the problem is far more essential, far more important topic than its solution. What we are dealing with is basically solution, but the formulation of the problem is the main problem. Once you formulate the problem, then you can find solution to that, and it's much easier stuff. So, and in order to do that, you have to ask questions, lots of questions. You have to be creative, you have to have some imagination, and so on. So, what are the questions we are asking for the product we are developing? So, what is the purpose of the product? What's the environment it will be placed in? What is the expected lifespan, for how long it will be used and where it will be used? What are the loads, even those mechanical loads, there's some environmental load, some maybe energy will be during the serviceability of the product. So all those questions we have to ask. What are the expected behavior? So what should be different from the common product, and so on. And then once you have those questions, try to find some reasoning for that. So what's the purpose? We said about flooring. We said about we could think about siding, covering the buildings, all of the buildings. Sailing would be also one of those. What's the environment we will use it in? Of course, if it will be siding, we should count that this product will kind of be involved in very moist environment. There will be sustained to rain, maybe wind, low wind will be. The temperature will rise up and down even within a day or within a year. There will be temperature changes and so on. What is the expected lifespan? For how long we wanted to have this product to carry certain quality? Is it 3 years, 5 years, 10 years? Can we renew it meantime, and so on? What are the loads? What about if we will have some flooring? Of course, we need to know how much load we can put on this flooring. If this will be sailing, how much wind can carry? It's usually some problem. For example, environmental loads. If we will have some sunlight on top of the surface shining for a few years, how the surface will behave? What will be the, for example, roughness? What will be the color change and so on? So those are the questions you have to ask for the product. And then it's in the last one I was speaking of. What are the expected behavior? Of course, once we will have this board and it will be used, let's say, next to the swimming pool, we surely will have some water splashing on top of the surface. We should count a little bit with the dimensional changes. We should count that the surface will be damaged a little bit. The aging will be a problem because of the UV light, sunshine. So all of those questions, technical questions, you have to ask in order to set some kind of a test what you would like to use it and measure it. For example, if we will have this flooring system, do you think it will be reasonable to find out what's the, I don't know, magnetic properties of this flooring? What is it for? Okay, and we can do hundreds or thousands of tests, but those tests should be related somehow to the usability of the product. Answering those questions. So there are. If you would like to see if the product is better or worse or it's useless, you have to do some decision making. And those decision making process, it's based on the standardized test usually, and comparison those standardized test values with the either standardized value or the values which are coming from common product behavior. Not all the time you can use standards, European standard, ISO, some Finland maybe, but right now we are all probably connected to EN standards. So once you fix those standardized tests, you can just measure them and compare whatever the standards say to this product good or not. Most of the times, or sometimes, we don't have a standardized test. Then we have to do some kind of comparison experiments or tests where we say this product is even better or worse than other product, and so on. So once we take all of this into account, and of course your knowledge of the testing and our capabilities of doing some processes and tests, we come up with these solutions for this week. We would like to do dimensional changes. Of course, we need to do it because once this material will be sustained to moist air or maybe rain, wood, as you know, it's kind of has a tendency to absorb water into the internal surface. So, and because of that, we should expect that there will be some dimensional changes. On the other hand, we did this high temperature treatment in order to decrease this dimensional stability. We have to check it if it is good or not. There is another question. For example, if we usually when you compress wood and it's sustained to varying moisture content, varying environmental changes, those dimensions usually tends to get back. We should check for them if it is the same for our products or not. Then you have a color and color changes. After me, our colleague will tell you much more about the color, how we measure it. But what's the purpose of that? Once we have sustained the material to in service condition, we should expect some color changes. How can we deal with this? How can we treat the surface even before or during the process in order to not have those color changes? Surface roughness, another property, what we will measure, and we will see how this can be measured, how can this be compared with the standards. Hardness test is also important. In one of the presentations, you will see how the hardness, why the hardness is important, how we can compare this hardness of our product with other materials, and so on. Abradability, that's kind of fancy word, but it's all about how material is able to carry some kind of abrasion test or wearing of the surface. And then of course adhesion. We did also adhesion for one reason, and adhesion in terms of how we can glue these materials together with another wood. Imagine once you will have improved technology in such a way that you will be able to create, let's say, 2 or 3 or 4 meters boards. But sometimes you have to add those boards together in order to create the final product, final flooring. So how you will glue it together? And is it what kind of glue will you use? So those kind of tests we will try to do, and in order to say if the product is good or not. Okay, Any question to that? Everything is clear so far. Okay. Good. Good. So I will ask my colleague, Dr. Čka,